Okay, here in Lesson 3, we're going to talk about something called conditional probability, which is a specific idea that shows up a lot in the following videos. We'll start by looking at this set of data right here. If we asked 100 students at a local high school what their favorite entertainment activity was, the results might be something like this. We asked a mixture of girls and boys, 60 girls, 40 boys, and we gave them three choices. They could choose reading a book, playing video games, or watching Netflix. And so here's the number of students. These are frequencies or counts here. For example, this 18 number means that 18 girls chose reading a book as their number one, and this 20 here means that 20 boys chose video games. Whenever we have a table of data like that, we should always add up the rows and the columns to get what's called the marginal values, the values in the margins, because often those values are useful in computing probabilities, but the data itself is really the value inside the table. Okay, so now that we've got this data, we could ask various questions about the probability of certain events. Probability would be a percentage, which is the ratio of two numbers from this table. So for example, I could say, if I select a student at random from this group, what's the probability of selecting a girl? Since each student is equally likely to be selected, this is an equally likely cases probability, and we would compute that by finding the number of outcomes in the sample space first and putting that in the denominator, and then going back and within that figuring out the number of outcomes in the event space, in this case the number of girls. So here the total number of outcomes would be all the students, so the entire table. There are 100 students in the table, so that's in the denominator of the fraction. And then we would say for the numerator, we want the probabilities only related to girl, which would be just this first column of students, which is 60. So that would be in the numerator, so the probability is 60 out of 100, or 60%. So if I select a student at random from this group, 60% of the time we should get a girl. Or I could ask, if I select a student at random, what's the probability of selecting a student who likes video games? So here the total number of outcomes is still all the students, which would be 100, and that's in the denominator. Right, this time the numerator would have to be the number of students who like video games, and that would be 32. There are a total of 32 students that like video games. So 32 out of 100, or 32%, like video games. But what if I ask this? What is the probability that a girl prefers video games? Now this is a little bit different because we're only considering girls. The total number of outcome isn't going to be the entire 100 students, it's only going to be the girls. So we're going to restrict ourselves to only looking at the 60 girls, and that means the denominator of the fraction this time is the 60 girls. And then the numerator would be specifically the number within that girls column only that like video games, which would be 12 out of the 60, or 20%. So if I have a girl, the probability that the girl prefers video games is 20%. Okay, this probability of 12 out of 60 girls is more complicated than the first two probabilities. The first two probabilities we found are what we call simple probabilities, right? But here we're talking about the probability of playing video games under the condition that we only look at girls. And because there's a condition that's stipulated, we have what's called a conditional probability. It's the probability given a certain condition. Okay, to indicate conditional probability, in the probability statement we have to indicate both the condition that applies to the denominator and also the event, which applies to the numerator. This is how it's actually written. It's written this way, P for probability. We put the probability of what we're finding, that someone likes video games, and then we put a vertical line, and then after that we indicate the condition. The condition is that we're talking only about a girl, right? So the event comes first, the probability of what we're finding, the event, and then after a line we put the condition. We're still finding the probability of someone preferring video games, so that's listed first. The condition is that we're choosing only out of the girls. Okay, so some things to notice. First of all, the condition, the thing after the line, that's always a portion of the sample space, generally not the entire sample space if it's a conditional probability. In this case, it's just this blue column of girls, so not the entire 100 students, it's just the 60 girls. So the condition forms a portion of the sample space, and we can refer to that as the conditional sample space. In other words, the denominator is still a sample space, but it's a sample space specific to the condition being a girl. So the conditional sample space is always a portion of the full sample space. On the left we have the event, and the event is a portion of the conditional sample space. So it's a part of the whole. So the conditional sample space is a portion of the sample space, and the event is a portion of the conditional sample space. Okay, another thing to notice is everything after the line, the condition, relates to the denominator. Everything before the line is the event, and that relates to the numerator. So we'll use that pattern frequently when we compute conditional sample spaces. Okay, how about this one? What is the probability that a student that we choose, that a student who prefers watching Netflix will be a boy? So if I write it that way, what's the probability that a student who prefers watching Netflix will be a boy? Okay, the most important, and actually sometimes the trickiest thing, is to decide, well, what part of that statement is the event and what part is the condition? So let's dissect the question sentence a little bit more. It says, what is the probability that a student who prefers watching Netflix will be a boy? Often there's a part that you can think of as being kind of in parentheses in the middle. And if you can think of like temporarily crossing it off, if the rest of the sentence still makes sense, that's identifying what the probability is about. So if I thought of this sentence as, what is the probability that a student will be a boy? And I just omit that, who prefers watching Netflix. Think of that as a parenthetical kind of portion in the middle of the sentence. Then this really, I could almost cross it off and it would still make sense. What's the probability that a student will be a boy? That means this is really a computation of finding the probability that someone is a boy. And that means that the boy is going to come first when we write the probability statement. Right? The part that's in the parentheses, who prefers watching Netflix, is a condition. And that means watching Netflix is going to be the conditional part. The stuff in the parentheses is conditions. So this is the proper way to write this probability. What's the probability of being a boy given the condition that we have a student who likes to watch Netflix? So now let's go ahead and compute that. First, let's identify the conditional sample space. The conditional sample space would be students who like to watch Netflix. That's going to be this row here. So there's a total of 46 students, and that's going to mean that that's in the denominator of the fraction. And then within that row only, inside the conditional sample space, the numerator, so the denominator relates to the condition, the 46 people watching Netflix. The number on the top is going to be something out of that condition, how many are boys. So inside the watch Netflix conditional sample space, how many are boys? That would be 16. So it's 16 out of 46, and this probability is correctly computed to be 0.3478. About 35% of people who like to watch Netflix are boys. Okay, one more from this scenario. What's the probability that a student is a girl if they prefer either playing video games or watching Netflix? Now, when I look at that sentence, it looks like I could cross off the if they prefer either playing video games or Netflix, because that seems to me to be the condition. This is, what is the probability that a student is a girl? Is a girl is what we're finding the probability of, so that would be the event, right? That they like video games or Netflix is the condition. So if I analyze that, the conditional sample space would be all the students in the video games and watching Netflix section. If you add that up, that's a total of 78 students, so that's going to go on the bottom of our fraction. Right? The event would be the people inside that blue conditional sample space who are girls, which would be the 12 and the 30 together, which is 42. That's why there are 42 girls out of the 78 students who meet the condition they like video games or watching Netflix. And that probability is correctly computed to be 0.5385. Okay, note it actually matters a lot which part is the event and which is the condition. If I say what's the probability of being a boy given that you like video games, right? Out of the 32 video game players, 20 are boys. That probability would be 62% about. But if I reverse that, if I say what's the probability that someone likes video games given the condition that they're a boy, out of the 40 boys, 20 of the boys like video games, that probability is 50%. Very different. So it matters quite a bit which one is which. Okay. Okay, using a table is a great way to visualize the sample space. It shows all the different combinations divided up into neat divisions, but there are other visual structures that we can encounter in probability, and one of the most common is a tree diagram. So a tree diagram shows how choices can be made in a sequence. In our table, there are really two things varying: the gender of the student, being a boy or girl, and then their preferred entertainment, books, games, Netflix. You know, we could, for the purposes of picturing this in another way, we could think of each of these as a choice that could be made. And if we choose in this way, the first choice we make is going to divide up the sample space into two or more parts that completely cover all the cases. Now when we do that, when we divide the sample space into multiple things to cover all the outcomes, those things are called partitions. Okay, so let's just say we're going to make the choice of gender and use that to partition the sample space into genders. That means we would have a column for girls and a column for boys. If we were to think of trying to make a tree diagram that represents that, it means that the first choice would be whether or not the student we select is a girl or a boy. So that will appear as branches in the first choice. And then for each choice there, girl or boy, we could say that the student either reads a book, plays video games, or watches Netflix as their favorite entertainment. So we could picture that as a tree. Okay, so if I wanted to add probabilities onto this tree, the first probabilities would be simple probabilities, right? They're the probability of having a girl out of all 100. And since we're talking about out of all 100 students, this is not a conditional probability. It's what we call a simple probability. The probability of being a boy would be the number of boys out of all of the 100 students. But the second choices would all be conditional probabilities, right? This probability here would be given that a girl was chosen, that means under the condition that a girl was chosen, what's the probability that the student would like to read a book? So this branch right here would be the conditional probability of liking to read a book given that you're a girl. This one here would be probability of liking to play video games given that you're a girl. Probability of liking Netflix given that you're a girl. This one down here would be the probability of liking Netflix given that you're a boy. So in the second branch of a tree, all of the probabilities are conditional probabilities. The probability of the second thing occurring given the condition that the first thing occurred. So for the simple probabilities, the sample space is the entire table, right? The probabilities for girl and boy, that's just out of the entire group. But for the conditional probabilities, the sample space is a conditional sample space of only that gender. So the probabilities here in red are all given the condition of girls. The probabilities down here in blue are under the condition that we're talking about boys. Here's the tree with all the probabilities filled in. Remember that you can pause this video and take a look at this in more detail. I'm not going to stop and explain it in great detail, but maybe let's just look at one. Let's take this one right here, for example. Okay, that's a conditional probability. It's the probability that given the condition that you're girl, that means out of the girls, which is 60, that's why the bottom of this fraction is 60. Then we want out of that the probability that somebody likes to watch Netflix, which would be 30. So 30 out of the 60, 30 out of 60. That's why that probability is there, because that's conditional. If I looked at, say this probability as to compare, that's a simple probability. It's just the probability of being a boy, period, out of all 100 students. So out of all 100 students, 40 of them are boys, so 40 out of 100. And you can look and check all those probabilities if you want to pause the video. Notice how within each of the sample spaces the probabilities always add up to 1, right? In the simple ones up here, right, 60 out of 100 plus 40 out of 100 is 100 out of 100. And that's because if we're selecting a student, they're definitely going to be a girl or a boy. That covers all cases, so the probabilities add up to 100. Once we've chosen a girl, we're in this conditional sample space here, red, right? 18 out of 60 plus 12 out of 60 plus 30 out of 60 adds up to 60 out of 60. So that has to always add up to 100%. Same thing down here. If a boy was chosen first, then 4 out of 40 chance of reading a book plus 20 out of 40 chance of liking video games plus 16 out of 40 chance of watching Netflix. Those also add up to 40 out of 40, which is also 100%. So we made the decision to divide up the sample space by gender and make gender the first choice, but that was completely arbitrary. We could also have decided to make entertainment the first choice, and we could have partitioned the sample space based on entertainment choice. and then we would have 3 choices in the first part of the tree, and then depending on what entertainment choice was made, you could choose to then say, now do we have a girl or a boy, and so on. The tree would look like this. And if we were to put probabilities in, now the probability of book or probability of games or probability of Netflix would be the simple probabilities, and the conditional probabilities would be of the form, for example, this one, the probability of being a girl given the condition that you like video games. So there's really no reason why one or the other would have had to been first. Okay, probability values, if you wanted to know, filled in, they look like this. You could pause the video and take a look for yourself. Okay, so just to summarize conditional probabilities and what it means, if I write a conditional probability, there's 2 parts to it. There's the event, and then the line, and then the condition. So the event is listed first. That's always what we're finding the probability of. But you can think of it as that the second part, the condition, always goes with the numerator of the fraction, or sorry, the denominator of the fraction, and the event is the numerator. Right? The conditional sample space is always a portion of the sample space, and the event is always a portion of the conditional sample space. Right? The probability is of the event, not the condition, so the event is always listed first. To figure out which is which, sometimes it's helpful to cross out part of the statement to see if it still makes sense that you're finding a probability. What's left is the event. So if you had, what's the probability that a student who prefers watching Netflix would be a boy? Who prefers watching Netflix appears to be a parenthetical comment, so that would be the condition, and this would be probability of boy given the condition Netflix. Okay, again, just to emphasize, the thing that comes after the line is the condition. That defines the conditional sample space. The thing that comes before the line is the event. That's the number out of the conditional sample space. That's the probability we're finding. Right? The condition defines the conditional sample space. This is actually a really important point that we're going to see later on when we use this idea. The conditional sample space is always a subset of the entire sample space. So if you have a table, it could be a single column or a single row. If it's a tree, it could be a portion of the tree. Okay. In a tree diagram, the first probabilities are always simple probabilities, but the second wave of probabilities are always conditional probabilities given the condition that the first one has been met. All right, that's, I think, everything we want to talk about as far as defining what conditional probabilities are. If you look at the examples section, we can work some problems of finding conditional probabilities. That would actually, I think, be really helpful, but I wanted to keep the concept to just the concept. Okay, we'll see you after the examples, and then we can move on to other videos which use this idea quite frequently.